So opacity is more because there's a lot of scattering by the newly freed electrons, because remember, helium plus became helium plus plus, meaning it loses an electron and becomes even more charged, and so there's more electrons in the mix of things scattering about, and so opacity is increasing. Next step is the light is absorbed at the bottom of the opaque layer, increasing the temperature and pressure gradient across the layer. So once again, light is absorbed at the bottom of the opaque layer, increasing the temperature and pressure gradient across the layer, because if you absorb a bunch of light, you're gonna get hotter. Driven by the, because it's more energy, driven by the increased pressure gradient, the opaque layer expands outward and cools. Because if you expand outward, that will lead to some cooling. Helium plus plus recombines with free electrons to form helium plus. The opacity, so because if you come back to a certain temperature where you can be less excited, then you can make helium plus again from helium plus plus. The opacity plummets because not as many electrons in the mix of things anymore. The opacity plummets and previously trapped photons rush outward through the newly transparent layer. The layer contracts and reheats to 40,000 kelvins, where the whole cycle begins again. It's cyclical, it's variable, pulsating, all of that. A layer with temperature of 40,000 kelvins is near the photosphere of the star. The central regions where the fusion reactions occur at much higher temperatures are unaffected by the opacity changes far above them. Is Ben here, by the way? Where is Ben? The fusion generates energy at a steady rate. However, the changes in opacity cause the energy to be released in periodic outbursts. Think of a pot of boiling water with a heavy lid. The water evaporates at a steady rate. However, the water vapor escapes only in periodic puffs when the pressure grows high enough to lift the lid. Stars in the instability strip, like the ones we've been talking about here, the Cephide stars and the RR Lyrae stars, and I'll show you the HR diagram where the instability strip is pointed out, and these two types of stars are close to each other on the HR diagram, which astronomers swear by. So the HR diagram is this like important thing in astronomy. Once again, the plot has luminosity in the y-axis and temperature in the x-axis. So I'll keep going. Stars in the instability strip have a helium ionization layer in which the natural period for the transition from opaque to transparent to opaque again just matches the period P for acoustic oscillations in the star. So acoustic oscillations and this helium ionization layer of the opaque to transparent, this period and the acoustic period is the same, it matches. So how, very interesting. Is there